Hi, this is Kevin at the Virtual Planetarium at Raritan Valley Community College. Welcome to our weekly Star Talk. Today we're going to be talking about the first day of spring, and we also have some exciting news about the James Webb Telescope, some exciting updates. But before we talk about that, let's talk about our upcoming moon phases. We have a last quarter moon on March 25th, we have a new moon on April 1st, and then a first quarter moon on April 9th. Okay, so today we're talking about the first day of spring. Today, March 20th, marks the start of spring, otherwise known as the vernal equinox or the spring equinox for those of us on the northern hemisphere. Equinox is a fun word which tells us a very important thing about this day. It's a Latin word that stands for equal night. Equa means equal and inox means night. And that's because this special day of the year, one of two special days like this, the day and the night are of exact equal length, 12 hours each. You've probably noticed how during the winter, daylight hours are shorter and then nighttime hours are longer, which is what makes winter days like so gloomy and short. While during the summer, daytime hours are longer and nighttime hours are less. Well, this happens because the Earth is tilted by about 22.5 degrees, which is actually the same reason why we have seasons. This tilt of the Earth causes the sun to be higher or lower in the sky, which makes the path of the sun in the sky either shorter or longer. Shorter during the winter and then longer during the summer, which makes the days, in turn, longer and brighter when the sun is higher up in the sky, and then shorter and, not quite as bright when the sun is lower. Well, the equinox is the spot right in between. So those dates that mark the start of the summer and the start of the winter are like the extremes right here, and then the equinox is that line right in the middle. Now, another fun thing about the equinox is that the sun actually rises and sets directly on the east and the west, respectively. Usually that's like not exactly the case. Here we have our planetarium software. We have it set up for our ocean view so we can actually see the horizon clearly. And if we go back a few months, let's say December 20th, and we go back to when sunset is happening. Let's bring the sun back. We see that the sun right here, that tiny little thing, is actually not setting directly on west. It's actually setting south of west. So we have west right over here. If we see our whole view right here, we have south right in front of us right now. It's setting fairly far south of west. But then if we move to like the later months, like summer months, if we go to, let's say, June 20th, and we have to go to sunset hour, so about 9 o'clock at night, the sun is, sorry, a little too far. The sun is further north of west. So here's the sun setting fairly close to northwest. So depending on the time of the year, the sun actually sets off of the exact points of north and west. Specifically, when the sun is lower in the sky during those winter months, it sets south of west, but when it's higher in the sky during those summer months, it sets north of west. But for this very special day, the equinox, it sets directly on west. So if we go back to March, and we go back to when sunset is, which is about 6:40 something, we see that the sun is setting and it's going to set directly on that W for west. So that's why this day is also pretty cool. And then on a more personal note, the equinox means that spring is here and that it's getting warmer. So personally, that just makes me like really happy. So it's a happy day overall. The trees are going to start turning green, the flowers are going to start blooming, and the gloominess of winter is finally going to be gone. So we're all so excited to be outside and do stuff again. So that's great. All right, like I said, we also had an update about the James Webb Space Telescope, and it's actually a very big update. So if you recall, first of all, here we have the page detailing the different steps for the James Webb Telescope. I'll put this in the description of the video. If you recall, James Webb flew up into space, folded up like this, like the main mirror right here was actually folded back. And also, a very interesting thing about the James Webb Telescope is that the primary mirror right here, we'll zoom into this a little more. Oh, that's all we can zoom in. This primary mirror right here is actually made up of 18 individual smaller mirrors. 18 individual mirrors that can move and be oriented specifically. These mirrors had to be aligned perfectly in order to work as one big mirror. Well, the big news is that they are finally aligned. The process is actually really cool. There's a fun video of the whole process where the astronauts that work on James Webb actually talk about this, so I'm going to link that in the description of this video as well. And then the whole process is actually fairly slow. So when they took this telescope and they pointed it at the stars, instead of seeing one star, they actually saw a bunch of different dots. They saw 18 separate dots, and each one of these dots is actually the same star, but for each different mirror. So when they saw all these stars, they were actually able to identify which mirror. So here we have the mirrors, they have them identified. So A1, 2, 3, 4, 5, and 6, and then B, and then the C mirrors. And they were actually able to identify what star image belongs to what mirror. And then they were able to align each mirror to have a mosaic like this. Oops, sorry, they're still moving it. There we go. And we see that the stars actually share the same shape as the mirror, so that's pretty cool. Here's a better picture of them a little bit more focused. Then each individual mirror actually had to be focused, had to be aligned perfectly, so instead of seeing these blurry little dots right here, we actually see stars. So that was another big step. And then after they calibrated each mirror individually and we see the same star 18 times, they actually move each mirror so that each one of these dots is directly on top of the next. So here we see that they're moving the inner ones in towards the very center, and eventually you come to a picture like this. Now, a weird thing about this picture is that we're only seeing one star, but we are seeing one star as seen by 18 different mirrors. Each individual mirror they're not working as one big mirror just yet. They're all still working as individual telescopes, and then we stack them on top of each other to get a brighter picture. So the scientists at the James Webb facility actually had to fine-tune the mirrors even more in order to get them all to work as one great big primary mirror like this one. So instead of having 18 small little observatory telescopes, we can have one great big telescope with all the mirrors working together to make effectively one bigger 6.5 meter telescope. And when they did that, they came up with this beautiful picture. So this is that one star that we were seeing there, but since all the mirrors are working together, instead of just seeing the brighter things, we have a bigger telescope and we can see so many other things in the background. All these little disks that we see there, these are all galaxies. So this is just really cool first show of how incredibly sensitive the instruments in the James Webb Telescope are. So it's just an incredible picture. It's not actually a science picture, it's just an alignment evaluation image. But it's so incredible to see that even for just this test picture, the telescope looks so promising, and I really can't wait to see all that future science that's going to come out of this incredible piece of engineering. Thank you so much for joining us today. Hope you learned something new. Hope you're just as excited as I am for the days to be getting longer and warmer. And if you like this video, be sure to give us a like. And if you haven't yet, please subscribe to our channel, and we will see you next week. Have a great week.